Good afternoon. These are the vector review notes. The projectile motion notes, I'm going to review 5.1 and 5.2, and then I will pick up at 5.3 with our second video and complete through 5.6. The vector review notes just covers some content that we've done in the past, but probably needs to be reviewed. So I'm going to talk about projectiles. Okay. So in the past, we've talked about vectors and scalars before, and now we're going to bring it into projectiles. So as I've said in the past, nothing ever goes away. So we're talking that projectile motion it's important that you understand projectile motion is broken into both horizontal and vertical components. So this is where your Pythagorean theorem is going to come up. Your linear motion, like understanding things in a horizontal motion, are constant, and anything in a vertical motion is dealing in free fall. Okay, we've seen this picture or something similar like it before. When we launched things straight up in the air, when we did the rockets and launched them up in the air, and when we threw a ball from one partner to another. Some of you got to it, some of you did not. But this is also the idea of hang time. You leave the ground, you're off the ground for a duration of time, and then you free fall back down. And gravity's playing a role in both the up and the down components here. Okay, so as a reminder, vector quantity includes both magnitude and direction. So 400 newtons down. Scalar is like time, 45 seconds. No direction on that. Okay, so this reiterates it. A vector could be velocity, acceleration, momentum, where a scalar is going to be time, mass, etc. So an example of scalars on this page would be 3 kilograms of sand added to 1 kilogram of cement. 5 liters of water is dumped out of a bucket that had 8 in it, resulting in a leftover of 3 liters. And if a trip is scheduled to take 60 minutes, but your buddy has to take a pit stop and needs to pee, and he takes like 15 minutes because he stops for candy while he's in there, now the trip takes 75 minutes. No direction on that one. Scalar quantities, how do they differ? Think about that, write that down, review it. All right. So the second thing we're going to review is velocity vectors when it comes to perpendicular. Okay, that's this and this. And I'm drawing on a computer screen, so my perpendicular isn't great. Usually at right angles to each other. Well, is at right angles to each other. Remember, a velocity vector deals in both number of magnitude and a direction, and the arrow represents the amount of the magnitude. So that's really important to understand. The greater the magnitude, the greater the arrow. So for example here, an airplane's velocity relative to the ground depends on the airspeed involved. So this is a tailwind. It has a tailwind of 20 kilometers an hour, working against an 80 kilometer per hour flight, or working with, gives it a total of 100 kilometer per hour speed. Now, if the plane actually encounters a 20 kilometer an hour headwind, this is a headwind, that's going to end up slowing down the flight. Okay? So, when you're flying with the headwind, you add when the arrows are the same direction, you add. When the arrows are opposing, you subtract. Okay? That kind of reviews that here. Take a moment to read if you need to. Okay, now what if there's a crosswind? I go 80 kilometers an hour north, and I'm going 60. The wind is going 60 kilometers an hour. east, right? So this is where we are going to end up doing or the parallelogram rule to determine the actual direction the plane gets thrown, and this is when Pythag shows up again. Okay, get to that in a sec. So when you're dealing with this, you have, we're going to label this side of the triangle A and this side B. And remember, this would be C because this represents this side of the triangle because they're equal to each other. So A squared plus B squared equals C squared. And you'd plug in the numbers you have. And you must square, oops, here it is. So 80 squared plus 60 squared equals C squared. And so it's the square root of A squared plus B squared equals C. Okay, that's important. You're going to need that later, but we've already used this before in the past. Okay, this just shows that same idea, the parallelogram rule. This tells you it's the diagonal. The diagonal of the square is the square root of 2. So if the sides are equal, if the sides are 1 and 1, so if I had 6 and 6, you could do, so 6, like was on the quiz, 6, you can say 6 times 1.414, that should get you your approximate answer. But that's only if they're not the same. Okay. Okay, so how is this going to affect that airplane? Will it go faster or slower? It'll still be faster, but it's going to have a different, like, end game. So it's going to have to, if it's flying this way, has that crosswind, it's going to end up over here. So it's going to have to account for that. So a good example I like to explain, when you're on the highway, so here's your friend in the fast lane. So this is after you guys have your license. And this is you come up and you're like, I think that's my friend. And you pull up and you see it's them, and then you're like being silly and you wanna race. I'm not telling you to race, I'm just saying in my past experience I've seen boys attempt to race. Well, here you're racing in the middle lane. You come up against a slow driver, you're going to have to move to get around them. So when you go through the process of moving, in order to stay on pace with your friend, you're going to have to push on the accelerator, because by changing that direction, it's going to pull you a little bit further behind them. Okay, so just by sheer, like, you will still be going fast, but you're going to end up distance-wise being a little bit behind them just due to your change in energy. Okay, so again, it increases your speed, but it does blow you off course, so you have to adjust for that. Okay, what is the resultant of two perpendicular vectors? Right, we call that your, what is the resultant? It is this and this, and this is where you're going to use Pythag. Okay, components of vectors. Right, that's where I'm going to stop. This is the review. I would expect you to practice the first couple pages of the Take Back packet.